Hello, you're welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says the cables are joined at the junction ring C. Determine the tensions in cable AC and BC caused by the weight of the 30 kilogram cylinder. So let's look at how you are going to solve this question. So as you can see, we are still on equilibrium of particles or bodies. Okay, so we are going to apply the conditions of equilibrium to solve this question. So let's look at that. Okay, so we have this system here, and then the first thing I'll do is to draw a free body diagram. Okay, I'll draw a free body diagram for this system here. I have a limited space there, so let me write it here. Okay, so let me go ahead and then draw the free body diagram. Okay. Okay, so this will be my free body diagram. Okay, so we are applying the conditions of equilibrium here, which is that the sum of the forces in the x should be equal to 0, the sum of the forces in the y should be equal to 0, and then the sum of the moment on the body should be equal to 0. But in this case, we have a system of what concurrent forces, which means that the line of action of all the forces have a common point, which is what C here. So we are going to use this the two force equations. So now let's look at the direction of the tensions, the direction of the tension forces. So you will see that from the figure here, okay, the weight of the, let's say, the block will be pulling down, okay, and then this system is in equilibrium. So what will happen is that the tension in cable AC and BC will try to make the system stable. Okay, so for that reason, since the weight is pulling down, they are going to pull in this direction just to keep the system in what equilibrium. So for that reason, we are going to have the tension in the cable CD to be in this direction, and then that of BC to be in this direction, and then that of AC to be in this direction. Okay, this is what you are going to have. So this is my free body diagram now, and then we are using the two force equations. Sum of forces in the x as direction should be equal to 0, and then the sum of the forces in the y as direction also should be equal to 0. Okay, so now let's go ahead. So you see that all the forces are at an angle, right? So you have to find their component. But first of all, let's look at the tension that will be in this cable here. Okay, so because of this weight that we have here, okay, the tension in that part of the cable, which is the cable CD, okay, will be as a result of the weight of the mass. Okay, so that tension, which will be TCD, okay, will be equal to 30 kilogram times acceleration due to gravity. So let's see what you are going to get for TCD. That will be 30 times 9.81. That will give us a value of 294.3 Newton. Okay, so let's take note of that. So now let's find the components of all the forces. Okay, let's find the components of all the forces. So let's start with TCD. Okay, let's start with TCD. Okay, so for TCD, when I take cosine of the angle, okay, which will be cosine of 15 degrees, that will be equal to the adjacent side, which will be the x component, right? So that will be TCDX over the hypotenuse, that will be TCD. So we're going to have TCDX, okay, to be equal to TCD cosine of 15 degrees, and then we are going to have TCDY, okay, TCDY to be equal to TCD sine of 15 degrees. This is what you're going to have. Okay, so now let's go to TAC. Okay, TAC, the tension in the cable AC. Okay, so for that one too, we are going to have components, right? So we're going to have the S component in this direction and then the Y component in this direction, right? So taking cosine of the angle, let's look at what you are going to do. So you have here to be 15 degrees, right? Okay, let me do it at this side. Okay, let's do it at this side. Okay, so you have here to be 45 and then you have here to be 90, right? So you are going to have 90 plus 45, right? And then we are going to subtract that from 180 because some of the angles in the triangle should give us 180. So we're going to have 90 plus 45. That will give us a value of 135, right? 135. So we are going to subtract this from 180, right? So 180 minus 135. That will give us a value of 45. So that means that we're going to have 45 degrees here also. All right, so taking cosine of that angle, cosine of the 45 degrees, okay, that will be equal to the adjacent side, which will be minus TACX, right, over the hypotenuse, that's over TAC, right? I negated it because it is moving the negative x axis direction, that's for the S component. We're going to have TACX, okay, to be equal to minus TAC, right? Cosine of 45 degrees, okay? And then you're going to have the Y component to be TACY, okay? And then that will be equal to TAC, okay? Sine of 45 degrees, okay? This is what you are going to have. So now let's look at the last force also, okay? So for that one, we are going to have the x component in this direction and then the y component in this direction. So that one also, the x component will be negative, right? So that will be TBC. Okay, so for TBC also, okay, we are going to have the cosine of, okay, you are going to have the cosine of 30 degrees, okay, the cosine of 30 degrees to be equal to the adjacent side, right, which will be minus TBCY, because the adjacent side in this case will be the y component, okay, so that would be tbcy, okay, divided by the hypotenuse, which is what TBC. So you're going to have TBCY, okay, to be equal to minus TBC, okay, cosine of 30 degrees, okay, and you're going to have TBCX to be equal to minus TBC sine of 30 degrees. Okay, so this is what you have. So now you have the components of all the forces, right? So now let's apply the equilibrium conditions. Okay, so we are using the two force equations. The first one will be the sum of the forces in the x-axis direction should be equal to 0. So let's consider the forces in the x-axis direction. We have the first one to be T CD, okay, cosine of 15 degrees, right? And then the second one will be minus TAC cosine of 45 degrees. And then the third one will be minus TBC, right? Sine of 30 degrees. Okay, this should be equal to 0, right? We know the value of TCD, which is 294.3, right? So you're going to have 294.3 cosine of 15 degrees here, right? And then minus TAC cosine of 45 degrees, okay, minus TBC sine of 30 degrees. This should be equal to 0. So let's make this our equation star. Okay, so now let's consider some of the forces in the y-axis direction to be equal to 0. For that one also, we are going to have TCD, okay, TCD sine 15 degrees, right? And then plus TAC, okay, sine of 45 degrees, okay, minus TBC cosine of 30 degrees. This is what you have. This should be equal to 0, right? We know the value of TCD, so we are going to have 294.3 sine of 15 degrees, right, plus TAC sine of 45 degrees minus TBC cosine of 30 degrees. This should be equal to 0. Okay, so now what you're going to do is that you're going to consider any of the equations, okay, and then make one of the unknown variables the subject. So what I'll do is that I will consider equation 2, okay, then I'll make TAC the subject. Okay, so let's look at that. So we're going to have TAC, okay, TAC sine of 45 degrees. Okay, I want us to use substitution method to solve this. This should be equal to TBC, okay, cosine of 30 degrees, right, minus 294.3 sine of 15 degrees, right? So I'm going to divide all the terms by sine of 45 degrees, sine of 45 divided by sine of 45 degrees, okay, all this divided by sine of 45 degrees. Okay, so now let's simplify this. I know that this will cancel out this, and then you're just going to have TAC here. Okay, so let's look at what you have on the right hand side. So you're going to have cosine of 30 degrees divided by sine of 45 degrees, right? This will give us 1.22 TBC, right? And then minus, let's look at what you have, 294.3 sine of 15 degrees divided by sine of 45 degrees. That will give us a value of 107.72, right? So this is what we have. So this will be our TAC. Okay, let's take note of this. So we are going to substitute this into the first equation. Okay, then we solve for TBC. So let's look at that. Okay, so for the first equation, we have 294.3 cosine of 15 degrees, right? Minus TAC, but we now know the value of TAC, so let's do the substitution. That will be 1.22 TBC, right? Minus 107.72, okay, bracket close, right? And then this is multiplying, sorry, this is multiplying cosine of 45, right? So let's bring it here, cosine of 45 degrees. So let's close the bracket now, okay, minus TBC sine of 30 degrees, okay, and then this should be equal to 0. Okay, so now let's simplify what we have now. So we have 294.3, okay, multiplying cosine of 15 degrees, okay, that will give us a value of 284.27, okay, minus, let's do with what you have in the bracket. We're going to have 1.22 TBC multiplying cosine of 45, okay, and then that will give us a value of 0.86 TBC, right? And then you're going to have minus 107.72 multiplying cosine of what, 45 degrees. That also gives us a value of minus 76.17, okay, and then we're going to have minus TBC sine of 30 degrees to be equal to 0. So now let's bring the terms out of the bracket. You're going to have 284.27 minus 0.86 TBC plus 76.17, right, minus TBC sine of 30 degrees. This should be equal to 0. Okay, so now let's group like terms. You're going to have minus 0.8. You're going to have minus 0.86 TBC, right? And then minus TBC sine of 30 degrees. Okay, this should be equal to minus 284.27, right, minus 76.17. Okay, so now let's finish this up. We're going to have minus 0.86 TBC minus sine of 30 degrees TBC, right? So that give us a value of minus 1.36 TBC, and then this should be equal to minus 284.27 minus 76.17. This will give us a value of minus 360.44. So let's divide both sides by minus 1.36 divided by minus 1.36. So this will cancel out this, and then we are going to have TBC to be equal to the negatives to cancel out. So we're going to have 360.14, sorry, 0.44 divided by 1.36. Okay, so that gives us a value of 265. Okay, we have a value of 265.03 Newton. Okay, this is what we have for TBC. So let's find TAC. Okay, so we're going to have TAC to be equal to 1.22 multiplying TBC, which is 265.03, okay, minus 107.72. So let's see what you're going to get. So you're going to have 1.22 multiplying 265.03. Okay, that gives us a value of 323.34, right, minus 107.72. So let's see what you're going to get. So 323.34 minus 107.72, that gives us a value of 215, okay, 0.62 Newton. So that will be the value of what? TAC. Okay, you might not get the exact answers I got, but you should get something close to the values I got because of the approximations. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel so that anytime I upload new videos you will be notified.